Hello, everyone. My name is Diganta. I'm in the consulting space, primarily in the AI analytics and the risk modeling space. First of all, thank you, Tree AI, for the invite. My topic today is evolving dynamics of model risks in the generative AI space. First of all, again, multiple experiments undertaken in the modeling world certify the fact that generative AI is clearly not flawless at this stage. We have a long way to go, especially the black box nature of generative AI makes it pretty challenging to interpret and trace the outputs. And the dynamic, open-ended nature of generated content poses huge challenges for us as validators and in terms of controlling the user's input as well as output. As we are aware, models could be manipulated by adversarial inputs, which could be carefully crafted. Many times we have seen it to cause incorrect or unintended outputs in many instances, for that matter. Training datasets are crucial. Issues like class imbalance, sampling bias often crop up, and even representational gaps at times extend into model outputs, leading to huge chaos in terms of bias or discriminatory results. We have seen it in case of traditional AI ML models, more so in the space of Gen AI. Could we go back to the existing model risk management prudential guidelines, the more famous ones being SR 11.7 and OCC 11.12 in US, or even SS 123, the Bank of England guideline for model risks? Possible. Perhaps it could offer a strong foundation for managing key risks associated with AI/ML models, both traditional as well as generative AI. Now we're shifting gear a bit. We should be asking the question like, where does the model fail, and can the business afford the failure, instead of asking the usual question like, does the model work? No, we have to shift it a bit, shift our attention towards model failure here. We need to play devil's advocate as model risk professionals here. Now, in Gen AI space, we talk about validating specific use case of the model. We are not that bothered about validating the inner workings of the model. Now, for that, validators need to have the requisite technical know-how and familiarity with lines of businesses for which the Gen AI models are being used, or at least we're trying to use. Examples are many. You talk about a chatbot used by a bank, devising trading strategies in the market space, anti-money laundering, or fraud detection. Now, for LLMs, identifying the underlying source of and mitigating biases, a classic problem, which is likely to be more difficult compared to traditional AI ML models. It's extremely important to consider the cost of running validation queries along with the cost of running the model itself quite early at the design phase of the model. Here it brings us to the human evaluation or human in the loop angle, which essentially involves quantitative judgment by experts and end users of the models, review by a human or an expert of a specific sample of LLM prompts and responses to identify the errors therein. Again, we need to talk about the explainable AI space here, techniques such as SHAP or LIME, local interpretable model agnostic explanations, or assigning importance to input tokens have been gaining currency in the LLM validation world of late. Let's spend some time on the responsible AI angle. The world researchers have been talking about it a lot, especially in the model risks world. Let's remember, first of all, what is Gen AI designed for? In simple terms, to generate the next token. It's not designed to generate a classifier for that matter, and for which a detailed MRM exercise could be quite pivotal here. Now, let's remember, foundation of responsible AI is always MRM, that's model risk management. Now, the problem here is the tech firms, including the fintech firms, today seem to be rushing to deploy the models without doing the necessary test. They seem to be lagging behind the validation framework a lot, which I've been noticing it over the last whole year. Now, testing LLMs could be quite expensive. We need to have test cases. Questions like how to evaluate could be quite tricky here. OpenAI, simply you cannot validate. How about the high-risk application cases, which are bounded? Yes. Validation could be handled because build a system for a bank to answer questions for specific products, let's say complaint summary by the customers. It's feasible to validate within the domain of the documents, which are bounded. We can always talk about validating the system there. Let's revisit the critical challenges in the model rigs world. First of all, again, conceptual soundness, which essentially involves data quality and suitability, spending time with input design and control, explainability and interpretability, which has been gaining currency over the last couple of years, as you are aware, as well as optimization and benchmarking of the model output. Outcome analysis, as well as ongoing monitoring of those models, which needs to be strictly looked into with utmost care. Key focus areas, again, pretty tedious and labor-intensive exercise. Testing comprehensiveness, which we'll see in a moment from now, be extremely, extremely important both in the traditional AI as well as generative AI modeling space. It will be more on the controlling data, inputs and unbounded outputs. We simply don't have any control on training data because the nature itself is so, because training data for LLMs comprise of data from various sources, social media, internet, simply everything you have seen in case of the US elections for that matter. Yeah, Twitter, Facebook, Insta, all over. So guaranteeing quality and suitability of data could be a very challenging task over here. No control on inputs as well, because a generic LLM chatbot, for that matter, is open to the public, which is open to the public, can receive a huge variety of prompts on a large number of topics, including those of very harmful and hateful nature. So we need to be extra cautious, but while controlling, it's a very, very onerous task. While coming to outputs, very wide range of outputs, which are unbounded, very difficult to evaluate because of the nature of unboundedness. Comprehensive evaluation, extremely difficult, and control, even with guardrails, could be very, very tricky, but near impossible task at times. A lot of research have been going on in that space among my community of model rigs professionals. Here it brings us to the question, should we aim at generic evaluation or a specific evaluation of a Gen AI model? Now, comprehensive validation of LLM, again, is near impossible. What is possible is comprehensive validation of RAG, retrieval augmented generation. As model rigs professionals, we will be asking questions within the boundary of a particular document, which happens to be finite, which makes your job a little easier there. Yeah. Now, validation of an LLM system for a specific business purpose, quite feasible, not a generic LLM evaluation though. We're dealing with comprehensive coverage and scalable automated test cases generation. And another solution is automated machine evaluation with sampling for human in the loop and validation and calibration therein. Identification of model weakness and diagnostic explainability could be tackled subsequently. How about the validation approaches? Let's talk. I'll highlight three validation approaches for Gen AI models here. One is a black box approach. Treat the model, validated model, as a black box. System is decomposed wherever possible to evaluate the intermediate steps there. Retrieval or embedding a generation subsystem in RAG are individually evaluated. That is the first approach. Second one, analysis and evaluation being facilitated by surrogate models, using an embedding model to explain and diagnose, measurement and matrix being computed using the embedding model. And third one, being the human angle, automated evaluation with human confirmation there. Analysis being done automatically by machine algorithm. Machines are good at that, as we know. And human evaluation to confirm and calibrate it. How about testing the models for high-risk decisions? Very important problem area that we face, especially in the banking world. Now, today, noise from LLM is simply deafening. Noise in the input, how the model will perform when the distribution or the environment shifts gear or changes. Something like typical Markov cases we used to deal with in good old days of modeling. Now, you apply model for high-risk decisions, model has to be explainable, the explainability angle, XML and stuff like that. It has to be conceptually sound and thoroughly tested, including test for fairness, comprehensiveness, robustness, so on and so forth. So you have to take it thoroughly with a battery of tests, because your black box model or Gen AI model cannot discriminate against ethnicity, gender, and stuff like that. We know that. I think none other than the banker would vouch for that kind of problems that we face, or we used to face as bankers while dealing with regulators in developed world. Now, model has to explain any adverse action. Again, an example from the banking world, let's say reject a loan or a credit card application on the basis of a black box model, Gen AI model, you have to be able to defend in front of a regulator. Otherwise, brace yourself for any kind of legal, soups. Yeah. Now, model has to be resilient in different environment. To conclude, overall, a multidimensional validation framework is the need of the hour for LLMs, which will encompass elements of model risks, data and privacy management. We know it. Some of you have been working the GDPR or CCPA kind of guidelines, or EU AI Act for that matter. So you know data and privacy well enough. Cybersecurity, legal and compliance risk, operational and technology risk, ethics and reputation, and vendor risks.